Hello, this is the presentation of our water network analyzer. It consists of about us, where you can see the brains behind the project. You can contact any of us through our email addresses, and you can read the brief documentation about the project. This is the home page where you can read a brief about the project authors and also the project. In this water network analyzer, a water network analyzer is a tool that is built based on the WNTR package, and you can use it for visualizing and analyzing water networks to improve the resilience of such networks. You can visualize a network by elevation. Looking at this, we can see that we have the red dots, which indicates the places where tanks and reservoirs are located. And then we also have the blue dots, which are the locations that are near the ground. You can also visualize the network by pressure. So we can see that despite the fact that what fluid is not flowing in the pipes, still the nodes, the terminal nodes that represent the tanks and the reservoir are having some pressure in terms of meter, because pressure depends on height. One may also decide to visualize the network by demand and pressure. Demand and pressure are some of the indicators of a problem in water networks. So in order to visualize that, you can select a link that you want to visualize and see how pressure changes in that link, and also the demand, how it changes in that same link. So with that, you can easily detect or if there's any problem in the network. Then also we have the analysis tab. In the analysis tab, you may be interested in knowing some of the metrics of that are useful in monitoring or managing water networks. One, you may be interested in knowing the total length of pipes in the network. Then you may also be interested in knowing the total cost of the network. All this can, and you may also need to make your network sustainable. And the sustainability index in this case is the greenhouse gas emissions, which is in kilogram per year. So like in this case, we have up to 2.57 million kilograms of greenhouse gases released to the atmosphere as a result of this network. So the hydraulic metrics includes the pressure analysis. You may want to know how pressure changes in one part of the pipe. And in doing that, you may need to set a threshold of frequency to see how many times does the pressure in that particular pipe changes or goes beyond the chosen threshold. So with that, all you need to do is to select the pipe of interest, and also you can adjust the pressure to see how many times it actually goes beyond that. And then also you can do a demand analysis. The essence of demand analysis is to visualize the availability of the water network. So in this case, of different elements of the water network. In this case, we can choose pipe 15 to see how available it is in the network. It is 58% available. Then we may decide to choose pipe 35 to see how available it is in the network. So this one is 100% available. It is available always. One of the parts of water network analyzer is it has the ability to carry out simulations. like water quality simulations and disaster scenarios. Water quality is very important, and although it is very important, water quality is a relative term. The water that may be fit for washing cars may not be fit for drinking. One of the factors that I use in quantifying water quality is the age, because water that is treated in the treatment plant, it can decay due to the chemicals that are used in treating the water. So the more the water spend time without being used, the more it's likely to harbor microorganisms that may be detrimental to health. So that's why the age factor is used in seeing how many part of the population can be used in knowing how many part of the population will be subjected to a particular water that is older than a certain age. So all you need to do, you choose age and you also run the simulation. You enter the simulation duration and you run. So when you do that, you can see the average water age in the network. Like in this case, it looks good. Only the tanks are holding water for too long. So in a situation whereby you have a water network that is bad, then in that case, you may think of setting up another water treatment plant in some of the areas that are affected by water that is of old age. So another thing that you may need to evaluate is how many people are going to be affected by that's the impacted population. So you also enter the simulation duration. That's in order to know how many people are going to be affected by water that is older than a certain age. So you choose the simulation duration and you choose your age threshold. That's the water age threshold. Let's say how many people are going to be impacted by water that is 24 hours of age. So after entering all the parameters, then you choose simulate. So you can see majority part of the population in this case, that's the population that are impacted in this case are not much. Majority of them are less than 2,500. In the last, that's those that will be affected with water that is less than 24 hours in this network. And another one is the chemical evaluation of the network. So introducing chemical in one part of the nodes will make the chemical to move through the fluid, through water from one place to another. Then in that case, in order to simulate this, all you need to do is to enter the starting node or the source node and also the second starting node. Then you also enter simulation start time, which can be 15. Then you enter the simulation duration, which we can pick 7 days, and you enter the maximum allowable chemical concentration based on regulatory bodies. Then you say simulate. So this will query the network to show you the segment of the network that is consuming water that is above the standard. So like we can see in this case, this arm is most of the nodes in this arm are actually above the chemical level. So we can see introducing chemical in one of these node will lead it to spread over time, over the next 7 days. So this can guide utility networks to know how to to know how to segment the network. One of the disaster model is earthquake. Earthquake is the aftermath of earthquake can be devastating, and it may lead to total collapse of networks, water networks inclusive. So in order to quantify how much time is it going to take to revive a network that is destroyed by earthquake, you can use this. All you need to do is enter the epicenter of that earthquake, the x coordinate and the y coordinate, that same axis. Then you also enter the Richter scale of that water. You press enter of that earthquake and you press enter. So here we can see that majority part of the rate of repair rates after earthquake is actually much in this network. That's if you look at the down part, the repair rate is more than where we have the reddish and the likes. So we can also simulate fire. When fire happens, firefighters do fight the fire using water from the water network distribution system. So in doing that, since they demand a lot of water in a short period of time, the overall pressure of the network will drop. So in order to simulate this type of problem using water network analyzer, all you need to do is to enter the node that is used in fighting the fire. The starting time of the fire, let's say it starts at 4. The end time of the fire, let's say it ends at 12. Then the demand that is normally associated with the fire, which we can say in this case is 4,000 gallons. So you just enter all the values. After that, it will show you the repair rate in the network. I mean the pressure difference in the network. The pressure difference between when there was no fire and when there is fire outbreak. So I will stop here. Thank you for listening.